Welcome back, Algebra 2. We're going to be going over the worksheet on the FOIL method. We're doing problems 1 through 8, so let's dive in. Let's see, number 1, we have x plus 1 times x plus 2. So remember the FOIL method, F-O-I-L, first, outer, inner, last. So we're going to multiply these first terms, the outer terms, the inner terms, and the last terms. So we're going to get x times x, or x squared. Outer is going to be 2x. Inner is going to be 1 times x. And last is going to be 2 times 1, or 2. Now, since we have like terms here, we have an x and an x to the same power, we can add these terms together. So we're going to land it, this comes down to x squared, and then we have a 2x and a 1x for a total of 3 x's, and then the 2 comes down, and we're done. Problem 2. This paper's going to drive me nuts. Problem 2. We have x plus 2 times x minus 2. Now you might recognize that these are conjugates, so there's actually a shortcut, but I'll use the FOIL method just so you can see the whole process here. So we're going to go first, outer, inner, last. First terms are x's, we get x squared, x times x. Outer is going to be a minus 2x. Inner is going to be a plus 2x. And last is going to be a positive 2 times a negative 2, which is going to be a negative 4. Now look what I can do here. We have a negative 2x and a positive 2x. These are like terms, but one's negative, one's positive, and they're equal, so sucker, those go away. So we land at just x squared minus 4, and that's our final answer. You'll notice that this holds true no matter what your first and second terms are inside the parentheses. If they are equal and separated by alternating signs, like this is, if you have the form a plus b times a minus b, the result is always going to be a squared minus b squared. So that's the form that we're talking about there. These are called conjugates, and this is a nice tool to have handy when you go in the other direction when you start talking about factoring. This is called difference of two squares, and it's always going to land at this. If we have a squared minus b squared, it's going to land at a plus b times a minus b. So that's a nice tool to have in your pocket later on. Number 3. We have x plus 2 all squared. Now it's tempting to just square this term and square this term and be done with it, but that's not how this works. That's not that doesn't follow the FOIL method. So let's break this out into x plus 2 times x plus 2. We're taking this term, multiplying it by itself, which is squaring it. Now let's use the FOIL method. First, x squared, outer, x times 2, inner, 2 times x, and last, 2 times 2. And notice we have like terms here. They're taken to the same power, so we can combine them. So we land it, the x squared comes down. We have 2x plus 2x for a total of 4x plus 4. And there's our answer. Again, you can't just take this exponent and distribute it to the 2 and distribute it to the x. It doesn't work that way. It doesn't work the same as if you had a multiplier here, that would work, but an exponent doesn't work the same way. This is how we're going to do this problem. Notice that if we have something of the form a plus b squared, the result is going to be a squared plus 2ab plus b squared, and we'll learn more about that when we get to factoring as well. This is a very useful tool to have when we get to a process called completing the square, which is one of my favorite ways of dealing with a quadratic. Number 4. We have xy plus 1 times x plus y. It's a little bit uglier, but we can still recognize the terms here. Here's our first terms, xy times x, xy times x, outer, xy times y, inner, plus 1x, or just x, and last, plus 1y, so plus y. Now these can simplify a little bit. We've multiplied this by x twice, so it'd be x times x, otherwise known as x squared times y. And this, we have x times y times y. Y times y is otherwise known as y squared, so it'd be x y squared, and then plus x and plus y. We don't have any like terms because these are taken to different exponents, so this is as simple as this gets. And we're done. All right, number 5. We have x squared plus y times xy plus z squared. Okay, still FOIL method. First, outer, inner, last. So first we have x squared times xy plus outer, x squared times z squared, inner, y times xy, and last, y times z squared. We can simplify this. We have an x squared and an x. That's an implied 1, so it's going to be x to the 2 plus 1, or x to the 3rd, times y, plus, and it looks like this is as simple as that gets, plus x squared z squared, plus, and we've multiplied this by y twice, so it's going to be y times x, or x y squared, plus, and this doesn't simplify at all, it's just y z squared. So this is going to be our final answer. I'm sorry if I slipped off the screen a little bit there. Number 6. We have x to the 3rd, x to the 1/3, plus y to the 1/2, all times x to the 2/3 y plus x squared y to the 1/2. Same idea. First, here are our terms here. First, outer, inner, and last. Okay, so we're going to have x to the 1/3 times x to the 2/3 times y. That's our first set of terms. Outer is going to be x to the 1/3 times x squared y to the 1/2 plus inner y to the 1/2 times x to the 2/3 times y, and last we have y to the 1/2 x squared y to the 1/2. Okay, can this simplify? Yes. We've got two x elements here. We're going to multiply our exponents. 1/3 plus 2/3 is 3/3, otherwise known as 1. So we're going to have x to the 1, otherwise known as x. And the y comes down. Plus, okay, we have x to the 1/3 and x squared. We're going to add those exponents. That's going to be x to the 2 and 1/3. otherwise known as 7/3. So x to the 7/3 times y to the 1/2. We have a y to the 1/2 and a y to the first, otherwise known as y to the 1.5 or y to the 3/2, times this x to the 2/3 that we'll put here. And okay. So plus, we have a y to the 1, let's move the x squared down first. And then y to the 1/2 times y to the 1/2. We're going to add our exponents. 1/2 plus 1/2 equals 1. So it'll be y to the first, otherwise known as just y. And it doesn't look like there's anything it can simplify, so that's going to be our final answer there. All right, number 7. This one's going to be fun. Zoom out a little bit here. All right, number 7. We have x to the 1/3, y to the 1/2, z squared, plus x to the 1/4, y squared, z squared, all that times x to the 1/3, y to the 1/2, z squared, minus x to the 1/4, y squared, z squared. Now it's tempting to just FOIL this one out, but remember this this conjugate property that we had. If we have the same term being added to a different term, and then that same term being subtracted, that same term minus that same term. In other words, this term is the same as this term, and this term is the same as this term, and we just have alternating signs. It's going to end up being this term squared minus this term squared. So that's going to be an easier way to do this. So what we can do is rewrite this as x to the 1/3, y to the 1/2, z squared, all squared, minus this term squared, x to the 1/4, y squared, z squared, all squared. All right, now all we have to do is multiply these exponents. When we're taking a group and taking it to an exponent, as long as there's no addition in here, we can just move this exponent down and multiply it by each exponent that we're dealing with. So x to the 1/3 squared is going to be x to the 2/3. Y to the 1/2 squared is going to be y to the 2/2. I'm sorry, I made a terrible mistake there. Well, no, I'm sorry. You're right. So I'm sorry. It's x to the 2/3. Y to the 1/2 squared is going to be y to the 1/2 times 2, otherwise known as y to the 2/2 or y to the first or y. Z squared squared. Multiply these exponents, we get z to the 4th. Okay, so there's that term. Minus, and let's do the same thing here. X to the 4th, 1/4 times 2 is 2/4, or 1/2. Y squared squared. We're going to multiply these exponents and get y to the 4th. And z squared squared is going to be z to the 4th. So a little bit of a shortcut. It looked like an ugly problem, but if we recognize that conjugate property, it makes it a lot easier. So we're on to number 8, the home stretch. We have x squared, y to the 4th, z, plus x to the negative 3, y, z to the 1/2, and all of this is squared. Now remember, you can't just, if we have addition inside these parentheses, we can't just take this exponent and move it to each one of these terms. We have to rewrite this basically as x squared y to the 4th z plus x to the negative 3 y z to the 1/2 times itself. But remember that property, if we have a plus b squared, that's going to be the same as a squared plus 2ab plus b squared. So let's see if that makes things easier for us. So we'll have x squared y to the 4th z squared plus 2 times, we'll multiply both these together, x squared y to the 4th z times x to the negative 3 y z to the 1/2 and plus b squared. So plus x to the negative 3 y z to the 1/2 all squared. Now this can simplify. So we're going to multiply our exponents here. X squared is going to be x to the 4th, because we're multiplying these exponents. X to the 4th. Y to the 4th squared, be 4 times 2 is 8, so y to the 8th. And z squared, we're just going to square that, so it's going to be z squared. Okay, plus, now we can take this 2 and just put it out in front. We have an x squared and x to the negative 3. 2 plus negative 3 is negative 1, so it'll be x to the negative 1. We have a y to the 4th and a y to the 1st for a total of y to the 5th. We have a z and a z to the 1/2. 1 plus 1/2 is 3/2, so it'll be z to the 3/2 plus, and let's do this last part. We're going to have x to the negative 3rd squared. Negative 3 times 2 is negative 6, so it'll be x to the negative 6 times y squared times z to the 1/2 times 2 is just 1, so it'll be times z. Now, you can move this x to the negative 1 to a denominator. So this is a correct answer, and you'll find that when you get to calculus, you'll prefer negative exponents like that, but some teachers may want you to put these negative exponents in a denominator. So alternatively, we could have x to the 4th, y to the 8th, z squared plus 2y to the 5th, z to the 3/2 over x to the 1st plus y squared z over x to the 6th. So both of these answers are acceptable depending on what any teacher you might come across is asking for. And we're done. We'll see you next time.